Now we are going to see the different factors which control the temperature. We will see 5 different controls on temperature starting from latitude. So first one is latitude. So we have different latitudes: 0 degree, 30 degree, 60 degree and 90 degree. And as we move from 0 degree altitude, that is a lower latitude, to higher latitude, we see decrease in temperature. So equator, the lower latitude are much warmer than the higher latitudes like polars. And the reason we have already seen, because the direct rays of the sun and the oblique rays of the sun. So latitude is the first factor. Second is the altitude. That is the increase in height above the surface of Earth. So increase in height above the surface of Earth. So if you see here, like this is a valley and this is a mountain top. So a person who is standing here with a thermometer and a person here who is standing with a thermometer, which will have lower temperature. So we can straight away say it is a person who is standing on the mountain on a higher altitude is going to experience much lower temperature or much cooler temperature than the person who is standing on the surface. There are two reasons for this. First is the surface area, right? So this mountain tops, they have very less surface area, while the more closer you go to the sea level, higher would be the surface area and higher would be the absorption of insolation from the sun. So in spite of being closer to the sun, the mountain person, he will experience cooler temperature because of the less surface area available for the absorption of insolation than the person who is standing on the surface. The second factor is the more closer you are with the surface, this is the surface and it is absorbing all insolation. So using conduction, it will make the near areas, the surface near areas will become warmer using conduction, and the more above you will go from the surface, lesser warmer it will become. So these are the two basic principles. First is the less surface area on the mountain top, and second is the warming of the surface of the earth for the above feature. Using conduction, it will decrease the temperature as you increase the height above surface. Third one is the continental versus marine. Third is continental versus marine environment. So you have two cities here. One is Delhi. This is Delhi. And this is Bombay. So Bombay, which is nearer to the sea, which is nearer to a big water body, would experience less extreme temperatures than Delhi. In Delhi, the temperature will reach 50 degrees in summers, and winters it will be hardly 5 degrees centigrade. So there is a huge extreme difference between the temperatures in the summers and the winters. While in Bombay, you will see 40 degrees, and in winters it may go down to 15 degrees. So less extreme temperature experienced in the marine environments because of the presence of moisture. So we will make this as a fact: the more moisture it is, the less temperature it will lead to. Let us understand it with another scenario. Here you have a city, and here you have outskirts of city, maybe some village where you have different crops growing, some houses, some trees, soils, and moisture in soil. So here we get an urban environment, a urban city which is made up of asphalt, glass, etc., with very little green space. So we get a high temperature. On the other hand, for the very near area which is outside the city, with a plenty of grass, crops, water bodies, small water bodies, here temperature may be relatively slow than the city area. The reason why we have a difference in these two environment, even when they are very relatively closer to each other, it is because of the latent heat is less in the urban environment, where latent heat is higher in the village environment because of the presence of moisture. So latent energy is the energy which is stored and which is ready for the evaporation. For example, if you're sweating, if your hand is sweating and there is a cool wave which passes through hand, you will feel cool, right? And why it is? It is because of the latent heat in the sweat and the evaporation. So latent heat, it is less in the city areas, and that is how the temperature would be more. And latent heat in the village areas, latent heat is high because of the presence of moisture in the soil. It is comparatively low. Another point is the land bodies and water bodies, their difference in the heating. So water bodies require 3 times of energy than the land bodies to get heated, or similarly they require more time to get cooled off. So that is the difference, and why there is a stream of difference in temperatures between summer and winters in the continental environment and in the marine environment. Third is, we started with the latitude. With increase in latitude, the temperature decreases. Then we talked about the altitude, that is the increase in height above the surface of Earth. And then we talked about the marine versus continental environment. And now the fourth one is the ocean currents. So let's take an example. Here we have the USA, and here we have Europe. These are the polar regions, and these are the tropics. So tropics, which are getting the direct rays of the sun, they are very hot. So what happens is, there is a warm current from the tropics to the polar, and we call it Gulf Stream. So what it is doing is, it is making polar less colder. They are cold, but they are making it less colder because of the warm current which is passing from the tropics to the polars. Similarly, there is a polar current to tropics, the cold current, and this is a warm current in oceans. So this cold current, it is making this tropics climates a bit moderate. Otherwise it would have been much hotter if these polar currents would not have been there. So these currents, ocean currents, the warm ocean current and the cold ocean current, the same thing replicates in the southern hemisphere as well, like where we see the warm currents from the tropics going to the polar regions, and a cold current from the polar regions to the tropical regions. It helps in moderating their temperatures. So ocean currents is one of the factors which controls the temperature. Finally, fifth one, we see cloud cover. So let us take 3 different scenarios here. First one is, this is my surface and this is sun. If you have a clear day, means no cloud cover, so here you have insolation, incoming short waves, and you will have outgoing long waves. So whatever heat it is getting absorbed, it is again getting emitted back to the space, right? So it will be a cool environment. Now second scenario is where there is now a cloud in between the sun and earth. So now what is happening is, this cloud itself is reflecting it back. Incoming solar radiations, it is reflecting back. So again you have cool environment on the earth's surface. Now the third scenario is where you have some cloud between the sun and the earth. You have some cloud, not the complete cloud cover. So now what will happen is, the the energy getting emitted back by the earth, it will get trapped in the clouds, and then again it will re-emit it back to the surface, earth's surface, and that is how you will have increase in temperature or a warm condition. So with clouds cover, we find temperature getting higher. So these are the five different factors which control the temperature. The general factors which control the temperature: the latitude, the altitude, the height above the surface of the earth, then continent environment versus the marine environment, then the ocean currents, and then the clouds cover. Let us focus now on another very important concept of atmospheric pressure. Now pressure, it is the weight which is exerted on an object by the atmosphere. So you can see this picture where atmosphere is putting a pressure on us, right? Air pressure is all around us. So atmosphere, it is waning down due to gravity, and there are difference in pressures, and these pressure differences are based on the different surface heating. So some places we will have more heating, we will observe the low pressure, and vice versa, where there is less heating we will see the higher pressure. And now what will happen with this is air will try to balance itself. Air will try to go from the higher pressure to the lower pressure, seeing it as a void, and these voids are the results of the heating of the surface. Let's see an example like how it is happen. So we see two columns here. We have two columns here. One we are cooling and second is warm. So now what will happen with this cooling? When we cool air, it will become more dense, and the more dense it will become, the more pressure it will exert on an object placed here in this column. So this is a very simple concept. The more dense the air becomes, more pressure it will exert on an object. So what will happen is it will sink. So it will reduce in column. The column will reduce in size, and it will exert more pressure, and it will be the area of high pressure, the result of cooling. Similarly here, when we are warming an air, right? So with warming, it is becoming less dense, and if it becomes less dense, it will exert less pressure on this object situated here. It will exert less pressure on it, and it will rise up. So here with cooling we are seeing a principle of sinking, and with warming we are relating it with rising, like rising balloon, a hot air balloon, it rises in air. Similarly here the air with rise, and it will create a low pressure. It will create a low pressure here. It will rise up. So this is the result of warming. So smaller molecules, where molecules are densely packed together, compressed, sinks towards the surface and putting more force on the surface. And on the other hand, the warmed gas, these molecules are spread up and warmed. So we have what pressure it will associate? It will be a low pressure. Let's open these two columns now. This is the high pressure and this is the low pressure. So here there is a vacuum, right? The whole air is rising up, and here we have a condenser which is going down. Now what will happen is this air will try to find a vacuum, and it will fill up this gap. So from high pressure to the low pressure, it will flow from high pressure to the low pressure, and the more the difference is in the pressure, the higher will be the velocity of the air. Higher will be the velocity or the speed of the wind. So air moving from the high pressure to the low pressure. Let's see the cross section of what is happening here. So this is my surface. Here I am cooling off, and here it is a warmer section. So here it is a high pressure and here it is a low pressure. So with low pressure, we see the air will rise up, and with the high pressure, air will condense, air will become dense, and it will move down, or it will sink. Now seeing a void here, the air will move like this to the low pressure center, filling this void, increasing the speed, and the speed will depend on the difference in the pressure gradient. More the gradient will be, the higher would be the speed. Now surface, above the surface there is a tropopause. Okay, it is a tropopause. Now suppose if you're having a water ball in your hand and if you throw it up, so if you throw it up, it has to go somewhere and it will hit the wall, the roof of your house, and then it will blows out. It will give in two directions, right? So same thing happens. The air is going up. Here is a tropopause, and it will diverge. So this is divergence. It will diverge and it will move like this again. Here it will see a void, right? So here it will see a void by the air which is sinking, and here it will converge. So there is a divergence and convergence. So this air will converge with the air present here. It will gain weight and again it will sink. So this is known as a Dien's principle of compensation. Dien's principle of compensation. So let me again explain it here. It's very simple and it's a very logical concept. So high pressure, we have air sinking, and other place where we have low pressure, that is making air less dense, it is going to move up. From high pressure to the low pressure, it will move. Seeing the void, air will move to the low pressure. It will rise up and reaching the top of the roof, like the ball which was there in your hand and which you threw up to the roof, it blows away. So similarly, tropopause, it will blow away the air, and it will be the divergence, that is moving away from each other. Divergence. So divergence, the air will again move to the area of high pressure where the air is sinking, and it will converge. Convergence. So that is how this is the phenomena which is happening in our atmosphere.